These notes are for lesson 6.5. This is on dividing polynomials. So before we start talking about dividing polynomials, let's talk about dividing in general. So let's go back in our time machine to middle school or earlier and say we wanted to divide 1,372 by 56. Okay? And we're going to do this by hand. So the way we do that is we take the dividend, that's this number, and the divisor, that's this number, and we write them in this fashion. And then we ask ourselves, how many times does 56 go into 1? And it doesn't. 56 go into 13? It doesn't. 56 go into 137? Well, that happens twice. So I do 2 times 56, that's 112, and then I subtract down. That gives me 25, then I bring down the 2, and I ask myself now, how many times does 56 go into 252? Well, that's 4 times. 4 times 56 is 224, and then I subtract down. And I get remainder 28. So we'd say our answer then is that 1,372 divided by 56 is equal to 24 plus 28, my remainder, over 56, my divisor. Hopefully that seems a little familiar, and you recognize that procedure. The procedure for dividing two polynomials is almost identical. So let's consider the following example. So just like before, I'm going to take my divisor, put that on the outside. I'm going to take my dividend, put that underneath, and then I'm going to ask myself the same kind of questions. But doing polynomial division, the only thing I really care about is my leading coefficients. So I'm going to ask myself, how many times does x squared go into 4x cubed? So to answer that question, I'm just going to kind of write on the side what I'm doing in my head. I'm doing 4x cubed divided by x squared. That gives me 4x. And then I multiply that to all of the polynomial. Gives me 4x cubed plus 12x squared plus 4x. And then I subtract down, just like we did before. Now, got to be careful when you're subtracting, because I got to make sure I'm distributing that negative to all places. 4x cubed minus 4x cubed gives me 0. 2x squared minus 12x squared is negative 10x squared. And then 3x minus 4x gives me negative x. And then I'm going to bring that 5 down. Now I'm going to repeat the process and ask myself, what times x squared gives me negative 10x squared? Just like before, I'm going to write my little note on the side to show you what I'm doing in my head. But to answer that question, I'm taking negative 10x squared and dividing it by x squared to get negative 10. And then I multiply that to all of the pieces. do that, I get negative 10x squared minus 30x minus 10, and then we subtract down. So remember, when we do that subtraction, that negative has to distribute to all the pieces. So negative 10x squared minus negative 10x squared is the same as negative 10x squared plus 10x squared. That's 0. Negative x minus a negative 30x, the same thing as negative x plus 30x, so that's positive 29x. And we have 5 minus a negative 10, that's the same thing as 5 plus 10, that's 15. And now if I ask myself, what times x squared gives me 29x, if I try to do the same thing, I get 29 over x. This is not a polynomial, so we're done. So my remainder then is going to be 29x plus 15, everything that's left. So my final answer I'm going to write is 4x minus 10 plus my remainder over my divisor. Let's do one more example of doing this before we move on. So let's say we have 6x to the 4th plus 5x to the 3rd plus 2x plus 8 divided by x squared plus 2x minus 5. Just like before, I'm going to start by writing my divisor on the outside, my dividend underneath, but I'm going to do something different here. Notice here we're going from x cubed to x to the 1st. We're missing our x squared spot, so I'm going to put a 0 there, just to kind of keep things all lined up neatly. Do you have to put the 0 there? No. Will it greatly help you keep everything lined up and prevent mistakes? Oh yes. My recommendation is you always do it. Okay, so I'm going to ask myself, what times x squared gives me 6x to the 4th? The answer is 6x squared. And when I multiply that to each of the 3 pieces, I get 6x to the 4th plus 12x to the 3rd minus 30x squared. And then I subtract down. When I do that, I get 0. 5x cubed minus 12x cubed is negative 7x cubed. 0 minus 30, minus a negative 30 is positive 30x squared. And then I bring the rest of my stuff down. And then I ask, what times x squared gives me 7x cubed? The answer is negative 7x. And I multiply that then to all 3 pieces. So negative 7x cubed minus 14x squared plus 35x. And then I subtract down. I get 0. 44x squared minus 33x. And I'll bring that 8 down. Then I ask myself, what times x squared gives me 44x squared? Well, that's just 44. I multiply that to all 3 pieces. So I have 44x squared plus 88x minus 220. Subtract down. 0. Negative 121x. And then plus 228. And you'll notice that there isn't any more we can do because there isn't a polynomial that I multiply x squared to get negative 121x. So that stuff is all just my remainder. So my final answer I'd write is 6x squared minus 7x plus 44 plus my remainder over my divisor. And at this point you should be saying, oh, Mr. Kulik, that seems exhausting. Is there possibly an easier way to do this? And yeah, there is. But before we look at that shortcut, I want to look at something called synthetic substitution. And we're going to use this in our shortcut. So we have direct substitution that you're already familiar with, whether you think it or not, you are or not. If I have like f of x equals x squared plus 5x plus 3, and I want to do f of 2, what do? I just plug 2 in for the x's. I get 4 plus 10 plus 3, or 17. You could also do something called synthetic substitution. So if we do the same thing, if we have my polynomial, and we want to know what it is when x is equal to 2, and we're going to take this number, and we're going to build this little graphic organizer, and this number is going to go out here. And then we're going to take the coefficients, put those numbers there. And this is the setup for synthetic substitution. So again, whatever x equals goes on the outside, and then the coefficients for the polynomial go inside. So to begin my synthetic substitution, I'm going to start by taking this first number on the inside and bringing it down. And then I'm going to take the number on the outside, multiply it to the number underneath, and then write the answer above, and then we'll add down. So 5 plus 2 is 7. I'm then going to repeat the process, so I'm going to take that 2, I'm going to multiply it to that 7, I'm going to write my answer here, and then add down. And this piece at the end, you'll notice, is the same thing we got here. And you might say to yourself, Mr. Kulik, why bother with this? It seems like a really difficult and kind of convoluted process to do something that was pretty easy. I'd say, I agree. But here's the thing. Synthetic substitution we can use to get around doing some kinds of polynomial divisions. It will be the exact same process, and the process is much easier compared to the long division. So, if the divisor is a monic polynomial, what do we mean by monic? We mean the degree is 1, and the leading coefficient is 1. So for example, you have to be in the form like x minus k. So notice there the leading coefficient is 1, and the degree is 1. That's what we mean by monic. Then we can use synthetic division. So let's look at an example. Let's say we have 7x squared. Oops, let's not say squared, let's say cubed minus 6x plus 9 divided by x plus 5. Okay. So we're going to do, I told you synthetic division is just like synthetic substitution, so I'll start with this graphic organizer. But in synthetic substitution, we have like x equals 5 that we put over here. How am I going to get that? I'm going to take the divisor, I'm going to set it equal to 0, and then I'm going to solve. And this number is what's going to go there. And then I'm going to take my coefficients, I'm going to write them in here. So there's my x cubed coefficient. Notice though I've gone from x cubed to x to the first. There's 0x squareds there. So I need to put a 0 there. Now it's unlike polynomial division, if you don't put the 0, can you still get the correct answer? But synthetic division, if you skip that 0, you will not get the correct answer. So you best make sure that you're not forgetting things. And then I have my -6 there. I have my 9 here. And I'll always get rid of some of these arrows so it's not so convoluted for when we go and start doing the synthetic division. Okay. Now we just do the synthetic substitution algorithm that we showed you before. So the setup, almost exactly the same. The only trick is we have to convert this divisor into x equals. And then from here on out, it's going to be exactly the same. That is 175. And that gives me 169. I could have picked some more annoying numbers. And then that's negative 845, and that's negative 836. And you're like, okay, so when did we do the division? The division is done, man. It is done. The only thing I have left to do is interpret how to get my division answer out of what I've done. So the piece that I need is here. These numbers are going to tell me the answer to this division problem. The way I interpret them is I start on the far right, and that first number is the remainder. The next number is the constant term. The next number would be the x coefficient. The next number would be the x squared coefficient. If there's another number after that, it would be x cubed coefficient, and on and on and on. But you have to start at the right side. The first number has to be the remainder. The second number has to be the constant term. And we keep building up like that. So we'd say our answer then is 7x squared. And then minus 35x plus 169 plus my remainder over my divisor. That's the x plus 5 from the very beginning. Let's do that one more time. So let's say we have 2x cubed plus 5x squared minus x plus 7 divided by x minus 2. So how do I start? I'm going to draw my organizer, and I'm going to take this, set it equal to 0, and solve. That number is going to be what goes on the outside. And then I'm going to use my coefficients. And put them there. Notice I went x cubed, x squared, x to the first, constant. I didn't skip anything, so there's no zeros that I need to put in. Begin by bringing that first number down. And then 2 times 2 is 4. Add down that's 9. 2 times 9 is 18. Add down that's 17. And 2 times 17 is 34. add down, that's 41. So this is my remainder, my constant, my x coefficient, my x squared coefficient. So my answer is 2x squared plus 9x plus 17 plus 41 over my divisor. And that's my final answer. That's fast. It's pretty cool. So what we may have noticed when we were doing the factoring in the previous section is occasionally we got to some factoring problems that we couldn't actually handle. So what if we had something like this? Notice this has 5 terms, so it's not going to be anywhere in my factoring tree. Oh, brother. So we should be able to factor this. Well, later we're going to learn how to factor without any hints, but in this section we're given a hint. You're given the hint that x plus 1 is a factor. So you'll be given something to factor and then a hint that something is a factor. So, if I know something is a factor, for example, 5 is a factor of 35. What that means is that 35 divided by 5 gives me a 0 remainder. In fact, it's 7. And if I know that 35 divided by 5 equals 7, that tells me 5 times 7 is 35. So that's how we go from a division problem to a multiplication problem. We're going to do the same thing here. So I'm going to start by dividing my polynomial by its factor. Notice that this is a monic polynomial, leading coefficient of 1, degree is 1. So I can apply the synthetic division. So I'll start by setting that piece equal to 0 and solving to get -1. And then I'll draw my organizer. And I have 1, -4, -6, +4, +5. And then proceed with my synthetic division. So if this is actually a factor, if x plus 1 is a factor, you must be getting 0 there for the remainder. If you don't get a 0 remainder here, it means one of two things. It means either, and most likely you've made a mistake, or 2, that the thing that they provided you as a factor isn't actually a factor. More than likely it's probably because you made an arithmetic error. So what this tells me is that x to the 4th minus 4x cubed minus 6x squared plus 4x plus 5, that was my original problem, divided by x plus 1, that was my hint, equals constant term x coefficient, x squared coefficient, x cubed coefficient, this. And if I rearrange this now, I know that my original problem is equal to my factor times the quotient. And now I'm in a factored form. And just like before in the previous section, I need to check to see if each of these pieces I could factor more. Well, that is linear. I know I can't factor that anymore. This piece has 4 terms, so let's check if we can use factor by grouping on it. So if I make 2 groups, the first group I can take out an x squared. The second group I can take out a -1. And that is indeed factorable. So if I bring the x plus 1 down, I have the x minus 5. And then I have the x squared minus 1. And now I need to check if any of these are factorable. any of these factors are factorable. So that's already we said was not factorable. X minus 5 is linear. That's not factorable. X squared plus 1, though, that is a difference of 2 squares. That we can factor. So that factors down to x plus 1, x minus 1. And now if we check to see if any of these are factorable, linear, 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 so we're done. This is completely factored. So notice what we did here. So recap, what we did is we took our hint and we used synthetic division to get a partially factored answer. We looked at the smaller piece, and now we were able to use some of our tricks from the previous section to finish our factoring off. And that'll be the common pattern for these sorts of problems. We'll use our hint to do a little bit of factoring. Hopefully one of the two pieces you're left with can be factored using some other technique that you're familiar with, at least until we get further where you are able to figure out on your own how to find those hints. And that'll do it for us. So you'll be all set to work on the 6-5 homework.